This is experiment number 3, that is regression analysis. Regression is a statistical technique used to find the relationship between variables and predict the dependent variable based on one or more independent variables. There are three types of regression. They are simple linear regression, multiple linear regression, and logistic regression. So let's see the code for every regression. First, we import pandas and NumPy as well as matplotlib for pyplot as PLT. So the next step is as usual, we need the CSV data and we're using wine regression.csv dataset here. The next step is cleaning the data. Here we use the imputation with the like imputing the values with the meaning, the missing values. So we create a copy and we try to uh, replace the null values or missing values with 0 or 1. And fillna is the command for filling null values. The next step is we choose the independent and dependent variables. So y is the dependent variable, whereas x is the independent variable. In this case, alcohol is the independent variable and y, that is the quality, is the dependent variable. So in simple linear regression, it predicts dependent variable using one independent variable. And there is only one input. And the formula for simple linear regression is y is equal to b naught plus b1x. And it is used in most of the cases since it is simple and easy to implement. The next step is we found using the formula and calculating b naught and b1. So we are finding x mean is equal to np dot mean of x and the y mean. We are finding mean of x and mean of y. Then substitute in the formula that is x minus x mean into y minus y mean divided by summation of x minus x mean whole square. And in this thing, similarly, we find b naught is equal to y mean minus b1 into x mean. So here we get the simple linear regression coefficients, that is b naught and b1. So we're formulating the equation to calculate y pred, that is the predicted value. Y pred is equal to b naught plus b1x. So this is the equation and we find y pred, that is the predicted value. And for this, in simple linear regression, we have the performance metrics such as sum of squared errors, that is SSE, which gives the formula y minus y pred the whole square. And we get the SSE here. And RMSE, which means root mean square error. So the square root of sum of squared errors divided by length of pi is the formula for root mean square error. Then we calculate the R square error. R squared error is summation of y minus y by y mean the whole square. And R square is equal to 1 minus SSE divided by SST. We plot the regression line with the data points. That is the actual data, alcohol versus quality. And the actual data, this is the actual data. The dots is the actual data, and this is the regression line. So this regression line tells us how the uh, quality of alcohol varies as we gradually go towards the values. And next, we predict y for any given x value. For any given x value, that is independent variable value, we calculate the new y value. So here we give the value as 8 and the predicted quality, that is y pred, is equal to this much. The next is multiple linear regression. So multiple linear regression predicts output. Dependent variable is there, and also there are two or more independent variables. So the equation goes like y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus so on up to beta n x1. So in this case, it is used in most complex cases, and in multiple linear regression, the data set is read again and the imputation is done for data cleaning with the mean. And here we can see that two independent variables, that is x1 and x2, alcohol and sulfates are used. Y is the dependent variable, that is quality. Then compute the coefficients using formula. So this is the formula where a linear algorithm, inverse of the matrix is taken and matrix multiplication is done. So this is how we find the constants B0, B1, B2. Then these are the multiple linear regression coefficients which we find using this formula. The next step, we calculate the y trait, that's the predicted value. Again, it's the independent variable is multiplied with the beta, the matrix which is already obtained. Then we again calculate the sum of squared errors and the root mean squared error and the R squared error. Then we predict y for any given x1 and x2, just like we did in simple linear regression. So here we give the x1 value as 40 and x2 as 70, and we get the predicted quality as 31.667. Okay, then the next is logistic regression. Logistic regression is mainly used for classification problems. It is a statistical method that is used to predict categorical outcomes like binary values like 0 or 1. And for example, we use it in email spam detection, or if we have to check whether a disease is present or not, use this logistic regression. And the formula for logistic regression is sigma of x is equal to 1 divided by 1 plus e to the power minus x. Here, as usual, we read the data set and then pre-processing is done in the copy of the data, and we choose the dependent and independent variables. Then here comes the sigmoid function. Sigmoid function is the S function. Okay. And since logistic regression does not give the output as a straight line, it is a sigmoid curve. It's like called a sigmoid curve. And there is cost function. Cost function is the loss or the error. How much error is there between the predicted and the actual value. And this is the formula for the error. I mean for the cost. Cost is equal to minus 1 by m into summation of y into np dot log of h plus epsilon plus y minus 1 minus y into np dot log 1 minus h plus epsilon. And this is gradient descent. Gradient descent is the steepest ascent. So how the function decreases with the values, that is gradient descent, and the x and y, variables that are independent and dependent variables are used here to find out how the curve changes and how it comes to constant over the time. And these are the number of iterations given. Alpha is the value 0.01 for the calculation. Then here we get the logistic regression theta values. Then we plot the iterations versus cost. As the iterations increases, the cost becomes constant. That is, the error is reduced and becomes very near to zero. This is in the beginning, the error is very high. Gradually, the error decreases, and at one point of time, it becomes nearly to zero. So, this is how it reduces the error. Here, the metric for logistic regression is accuracy of the model. We can check the accuracy of the model by calculating the upright class. That is, we calculate if the value is above zero point 0.5, then it belongs to class 5. If it is below zero point 0.5, then it belongs to 0. So this is how we differentiate between the classes and the 0 as 0 and 1. Thank you.